going to be looking at the unit circle and circular functions, and this is actually a review because we have talked about both of these things before, but we're going to review the topic and then we'll expand on it a little bit as well. I think one of the things we need to do first is to define the unit circle. The unit circle is a circle with its center at the origin with a radius of 1. Also, if you recall, we used to have this equation that we use quite a bit, x squared plus y squared equals r squared, that came from the Pythagorean theorem back when we were first starting our trig class. But in this case, if we know r is equal to 1 for the unit circle, we have this nice equation of our unit circle. X squared plus y squared equals 1 squared, and of course 1 squared is just equal to 1. So that gives us a bit of a start on our unit circle. Now if we talk about the trig functions for our unit circle, if you'll recall, let's say we have sine theta from my unit circle. That ratio was y over r. But for our unit circle, r is equal to 1, so that's just equal to y. So for cosine of theta, if you'll recall, that was x over r, but for the unit circle, r is equal to 1, so cosine of theta is just equal to x. Now we can do this with our other trig functions as well. Let's do tangent of theta. If you recall, tangent of theta, that was y over x. Now there's no r to replace here, so that ratio stays the same. But if we look up here, y is equal to sine, and x is equal to cosine. So remember, tangent theta can also be rewritten as sine theta over cosine theta. Now we also have the reciprocals. The reciprocal of sine is cosecant. So the cosecant of theta would be r over y. R over y then would be radius of 1 over y. So cosecant theta is 1 over y, which is the reciprocal of here. We can also think about that as just 1 over the sine of theta. Same thing for secant. Secant theta would be r over x. It's the reciprocal of cosine. R is 1, and of course my value for x I can say is just plugging back in for cosine of theta. So it's the reciprocal of 1 over cosine. Now this is important to keep in mind that this is only true for the unit circle. A unit circle has to be a circle centered at the origin with radius 1. I think the only thing that we haven't done here is cotangent of theta. Cotangent theta is x over y, and of course x from up here we know is cosine of theta. Y is sine of theta. So what we have here then is the reciprocal of tangent. Tangent is sine over cosine. The reciprocal of cotangent then would be cosine over sine. Now these are going to be very important to remember, and you'll want to have these memorized. Now there's also another little interesting connection that we can make here with arc length. Remember, we've learned about arc length before. Let's go ahead and sketch up a unit circle. Unit circle has origin at the center, radius of 1, so that means any point on the circle from the origin to any point is going to be equal to a radius of 1. So let's say we have this point over here. It's in the second quadrant. It doesn't matter which quadrant that it's in, but for this case we'll put it in the second quadrant. Here we can see that radius is equal to 1, and here I have theta, and we'll assume that theta is in radians. So for the unit circle, we can still use our standard formula that we used for arc length, and if you recall, arc length is equal to s, and the formula for that is s equal r times theta, where theta is in terms of radians. Well, for the unit circle, r is equal to 1. And of course 1 times theta is theta. So I just get s equals theta. So for the unit circle, the arc length is equal to that central angle. So in this particular case, the arc length from this point at 1, 0 through pi over 2 radians to this point xy, this value of theta is also equal to the arc length. So in this case, s equals theta, and this only happens when the radius is equal to 1. Now we already talked about the equation of this as well, but I just want to give you a quick reminder. X squared plus y squared equals 1 squared. X squared plus y squared equals radius squared. 1 squared is 1. So those are a couple things to keep in mind. A lot of times when you're working through your MyMathLab homework problems, they'll give you a trig function, let's say tangent, and they'll say, what is the tangent of s? But remember, s, this arc length for the unit circle then, just relates back to this angle theta, this central angle right here, if my pen will write. So let's go ahead and start from scratch and let's fill in an entire unit circle. And this will be something you definitely want to have memorized. It was on our last, I think it was on our last handwritten homework. It'll show up a lot. It'll show up on another handwritten homework on exams as well. So the sooner you memorize this, the better. So we're going to spend a little bit of time kind of working through each step of this. And really, if you have the first quadrant and the quadrantal angles memorized, this goes pretty slick. So let's go ahead and get started, and let's do degrees working around. And we'll put the degrees in the dotted lines, and we'll put the radians in the solid lines next to each one. So here's our dotted line. This is 0 degrees. This is 90 degrees for our quadrantal angles. This is 180 degrees, and this is 270 degrees. Now when I complete that full spin around this unit circle, I'm back to the same spot I started, but I've gone 360 degrees in the amount of my rotation. Okay, so those are our quadrantal angles. Now let's think about this as the unit circle. So if this is the unit circle, that means the distance from the center or the origin out to any point on the circle is a radius of 1. So the radius from the center to this point is a distance of 1. Well, that's also my x value because I move 1 unit along the x-axis and I move 0 in the vertical direction, so my y value would be 0. So remember, each one of these ordered pairs that I'm looking at here is an x value and a y value. And for the unit circle, this translates directly into cosine of theta and sine of theta. So those are for our quadrantal angles. Now here for 90 degrees, from the horizontal axis to up here, I don't move left or right. And so I would have 0 in the x direction, and I'm moving up 1, so I'd have 1 in the positive y direction. So from the center to this point is a distance of -1. I'm moving in toward the left, so that's a -1. And I'm moving 0 vertically. For 270 degrees, I'm moving 0 units left or right. Horizontal, that's my x value, and I'm moving down 1 vertically, so that gives me my value of -1. So if you can get these quadrantal angles to start with, that's good. Now the next ones I like to fill in are usually the 45s. The 45s split or bisect each of the quadrants. So here would be our 45-degree angle right through here. So 45 degrees. Now remember, we can convert all of these angles. So 45 degrees, I would just multiply by pi over 180. 45 goes into 184 times, so I get pi over 4 here. So 45 degrees is pi over 4. Now every angle that's a multiple of 45 will also have a denominator of pi over 4. However, some of them can be reduced, and we'll see that in some cases. So here I have my 45 degrees pi over 4. I could also then come in this direction and bisect quadrant 2, and that's going to be, here's our 1 pi over 4, here would be 2 pi over 4, and here would be 3 pi over 4. Okay, and I forgot to put in the radians for the quadrantal angles. I'll go back and do that in a second. And this would be 3 multiples of 45. So 45, here would be our 90, and here would be 135 degrees. Okay, another multiple would be 4 pi over 4, would put me at 180. And this would be 5 pi over 4, would put me at 180 plus 45 would be 225 degrees. I think I might have messed up my, I think this is supposed to be 135 on the dotted line. And 3 pi over 4 here. So here's 5 pi over 4. Okay, here would be 6 pi over 4 to get us to 270. Here's 7 pi over 4 that bisects the fourth quadrant. Now if I'm adding 270 plus 45 degrees, that would be 315 degrees. Now if I take 315 plus 45, that would bring me back to 360. 7 pi over 4 plus another pi over 4 would be 8 pi over 4. 8 pi over 4 reduces to 2 pi. So let's go in and throw these radian measures in. So if I'm looking at 180 degrees, that's pi radians. Well, half that distance would be 90, would be half of pi, or pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2. And of course 2 pi. Now a lot of these angles, like 2 pi, I'm going to be able to hit those with a 30, a 45, or a 60, but the important part is just to always reduce them, and then that multiple will always reduce to 2 pi. Okay, so now we need to talk about the cosine and the sine. Well, we have these memorized from before. We know that the cosine and the sine for 45 degrees is the same because they are from an isosceles triangle. So if we take a right triangle and we have two equal angles and a 90, those equal angles have to be a 45-degree angle. So that tells me I have two equal sides as well. So that's the square root of 2 over 2 and the square root of 2 over 2. Well, those same values are going to go here. They're going to come down here. And they're going to go over here as well. Now the trick to this is I need to figure out which ones are positive and negative. So in the second quadrant, so this is quadrant 1, quadrant 2. So in the second quadrant, cosine of theta is negative, sine of theta is positive. So cosine of theta is negative, sine of theta is positive. In fact, if I wanted to, I could fill all these in as negatives. Now down here in quadrant 3, the cosine of theta is negative and the sine of theta is negative. They're both negative. So I could mark all of these cosines negative and all of these sines negative. Over here in quadrant 4, cosine of theta is positive and the sine of theta is negative. So all these cosines are going to be positive, the sines are negative, so I could run through and put in those negative signs. If you wanted to, you could do it that way. There's many different ways that you could build this. Okay, so next I want to work with our 60 degrees. So actually let's do 30. So here would be our 30 degree. And this would be our next one. Another multiple of 30 would put us right here at 60. Okay, but they have two different reference angles. So when I talk about multiples, 90 would be another multiple. I'm really talking about who has reference angles of 30 degrees. So if we keep working around the unit circle, 60 plus 60 would be 120, but the reference angle would be 60. Another 30 would be over here at 150 degrees. Another one would be here at 210. And let's see, here's another one at 330. Okay, so converting 30 degrees, and again, these are ones that you want to have memorized. We'd multiply by pi over 180. 30 goes into 186 times, so I'm left with pi over 6. So multiples of 30 degrees will end in pi over 6, and I might be able to reduce them to something else, but before they reduce, they could have been just standard pi over 6 angles. So 30, 60, 90, 120, 150, 180, there's a lot of different multiples of 30. But the ones I really only want to relate this to are the ones that have a reference angle of 30 degrees. Now notice this goes straight through from the 30 in quadrant 1 to the reference angle of 30 in quadrant 3. And the same thing here in quadrant 2 to quadrant 4. So this is 1 pi over 6. This would be 2 pi over 6 right here at 60. 3 pi over 6. 4 pi over 6. And this one's 5 pi over 6. So if you wanted to convert each of these, you can, but it's actually kind of easy to just multiply or add these pi over 6's. So here we are at 5 pi over 6. This would be 6 pi over 6. Now this would give us 7 pi over 6. Okay, next we'll have 8 pi over 6, so that's going to put us right here at 8 pi over 6, but that would reduce. This would be 9 pi over 6, but that reduces. 10 pi over 6, and here we'd have 11 pi over 6. So 11 pi over 6. Now when I get back up here, I'm 12 pi over 6, which reduces to 2 pi. So I already have all my angles marked in now. Now I need to just go in and fill in my sine and cosine values. Well, if you want to go develop your cosine and sine from the Pythagorean theorem, or you can use your right triangle that we've worked on before, it doesn't matter. You can use either approach. I think it's best if you just get them memorized. So the sine of 30 degrees, or the sine of pi over 6, is 1/2. And the cosine is square root of 3 over 2. And you just need to have those memorized. So what I do then is I come over and I find all the angles that have a reference angle of 30 degrees, and I fill in those same cosine and sine values. Now here I'm in quadrant 1, so it's negative. I fill in the same cosine and sine values, same cosine and sine values. And we'll go through and check the positive and negative when we're done. Now another thing I want you to remember is 30 degrees plus 60 degrees is 90. So they're called complementary angles. They're co-functions of each other. So that means co-functions, the cosine and the sine will swap. So the sine of 30 is 1/2. Well, that translates to the cosine of 60, because they're complementary co-functions, is 1/2. And the cosine of 30 becomes the sine of 60. So I can go spin around the unit circle and fill those in as well. And again, we will double check to make sure all of our positive and negative values are correct. So if you notice, there's a pattern here as well. So I go from quadrant 1 down into quadrant 4, quadrant 2, quadrant 1 to quadrant 3. Then I'm going from quadrant 2 to quadrant 4. And I need to fill in these multiples as well. So here I'm at 60 degrees. 60 degrees converted to radians is pi over 3. This would be 2 pi over 3, or 120 degrees. This would be 3 pi over 3, which reduces to pi. This would be 4 pi over 3. So I have 180 plus 60 would be 240. This would be 5 pi over 3. Okay, and if we're at 240 and I add 60, I'd be at 300 degrees. Now let's double check everything. In the quadrant 1, sine and cosine are both positive. So here I have all positive values for sine and cosine. Over here in quadrant 2, cosine should be negative. So each of these cosines is negative. Sine should be positive, and each of these sines is positive. So I'm good there. Down here in quadrant 3, they're both negative, so cosine, sine should be negative for each. And in quadrant 4, cosine is positive for each and sine is negative for each. So it matches. One thing I want to do is be careful. This negative sign almost runs into the square root sign. So I'm going to make sure that's really clear that that's a negative root 2 and not just kind of an extended root sign. So negative root 2. So you need to have this memorized. However you choose to memorize it is up to you. I think working on the first quadrant, if you can memorize the first quadrant, everything rotates from there. And then as soon as you know your quadrant values of positive cosine and negative sine, etc., it's really easy to fill everything in from there. But focus in on that quadrant 1 and then kind of expand from there. Now from here we can answer all sorts of questions that you might come across in your MyMathLab homework. So here's an example from MyMathLab and some notations that you'll see that are a little bit different. Everything that we were looking at, we always say the sine of theta. Theta represents the angle, but remember for a unit circle, the theta is equal to that arc length. So they're using S here for the arc length, but remember the arc length is just equal to theta. So don't let that throw you off. So the sine of negative 3 pi over 2. Well, the first thing that might be handy to do is to go ahead and throw up a unit circle. Negative 3 pi over 2, I'm moving in the negative direction, so I'm going to start here. So this would be at negative pi over 2. This would be at negative pi. And this would be at negative 3 pi over 2. So this would be the same as the sine for 90 degrees, or the sine for pi over 2. Okay, so this is the same for the sine of 90 degrees. So the sine of 90 degrees from this point, if you remember your unit circle, is 0, 1. And so the sine is equal to that value of 1. So if you can relate the rotations to a positive angle, these make these quite a bit easier. Now, of course, from here, cosine is going to be nice because I already have everything written out. So the cosine of negative 3 pi over 2 will be the same as the cosine of 90, which we can see from our picture is 0. Last is tangent of negative 3 pi over 2, which will be the same as the tangent for 90. Tangent is sine. So this would be the sine of 90 over the cosine of 90. So the sine of 90 was 1, cosine is 0. So this is not 0. 1 divided by 0 is not 0. This is undefined. Okay, so I'd have a value here of undefined. And that's definitely possible. So if you come across that, just double check your work to make sure you're on the right track. Okay, so for this next one, we're asked to find the cosecant of pi over 4. And the instructions usually say something about don't use a calculator, or they might also say simplify your answer, including radicals, use integers or fractions. So that means they're not going to count a decimal as correct. So you can't just plug this into your calculator. You need to actually find the exact value, whether it's a fraction with a radical. Well, if you remember your trig identities, I should be able to rewrite this as the cosecant of pi over 4, and that is a standard angle. Cosecant is 1 over the sine of pi over 4. Well, if you have your unit circle memorized, the sine of pi over 4 is the square root of 2 over 2. When you divide by a fraction, you multiply by the reciprocal. So this is the same as 1 divided by square root of 2 over 2. When we multiply by that reciprocal, I get 2 over root 2. And then 1 times 2 is 2. And I get 2 over root 2. But then I rationalize the denominator. So I get 2 root 2 over 2. The 2's cancel, and I'm left with just the square root of 2. So the cosecant of pi over 4 is the square root of 2. Okay? So this works out really slick if you have your unit circle memorized, and these actually work pretty fast. The more you know about your unit circle, the better. And the sooner you have it memorized, the easier it will be to work through your homework. It'll work faster on your exams. So all of those will be good things when we're working through these. Now sometimes we're not given a standard angle to work with. So what do we do if we're not given a standard angle? Well, usually we need to have a calculator involved. So let's go ahead and pull in a problem that is going to require the use of a calculator. So this one says find a calculator approximation. So this is not an exact value like with a radical or a fraction. They're saying find a calculator approximation, and they specifically say to round this to 4 decimal places. So let's go ahead and grab open a calculator. And then once we get the calculator open, we need to double check that we're in radian mode. Okay, so for this problem it says find a calculator approximation to 4 decimal places. So we need the sign of 0.6824. Now notice there's no degree mark here, and because there's no degree mark, that means we're in radians. So up here on your calculator, you'll notice that it says degree. You always need to double check your mode. So to change this to radians, because we are working in radians, we can just scroll down, find radian, and hit enter. And if you notice that that's solid flashing now, so I know I'm in radian mode. So second quit to get me back to my screen, and I'd say the sine 0.6824. Now I'm in radian mode, so I get 0.630657 630657. So that's way past 4 decimal places. So 4 places 1, 2, 3, 4. This would be my 4th place. So I take this value of 5, and since it's 5 or larger, I would round this up to a 7. So my final answer here would be 0.6307. Now one of the most common mistakes to make while you're working these types of problems is your calculator being in the wrong mode. So always double check that your calculator's in the correct mode, whether you're working with degrees or radians, so you can quickly switch back and forth and always be aware of that. Now remember, I can also find the other ratios. For instance, I can find cosecant by taking 1 over the sine of a function. I can find secant by 1 over cosine, and I can find cotangent by taking 1 over tangent. Okay, let's go ahead and look at one where it says not to use a calculator, and they want us to just test our basic knowledge of what a radian is and how it relates to the unit circle. Okay. So it says without using a calculator, decide whether the function value is positive or negative. Well, let's figure out where the radian measure is. So this is the cosine of 3 radians. Well, if we remember our circle, and remember your radian measures, here I'm at 0, here I'm at pi over 2, here I'm at pi, here I'm at 3 pi over 2 to kind of get us started. Well, let's go ahead and grab our calculator and figure out what pi over 2 is. We know what pi is, it's 3.14. So pi over 2 will be about half that, second pi divided by 2. So that's about 1.57 up here. So this is about 1.57 radians. This is about approximately 3.14 radians. So 3 radians would be really close to this. So 3 radians would be something like theta equals 3 radians. Well, that puts me in quadrant 2. And in quadrant 2, I know that my cosine is negative, and I know that my sine is positive. So is the value of the function cosine 3 positive or negative? And it should be negative because I'm in the second quadrant, and in the second quadrant, cosine is negative. And again, that's that less than 0 that has the same meaning. Okay, let's go ahead and look at another one. We'll get to some more difficult ones in here in a little bit. This one will be a good one. So this one we need to remember what we've already learned about using the unit circle and some formulas as well. And we'll also need to remember our trig ratios. So for this problem, most of the good information is on this circle over here. It says the figure shows an angle theta in standard position. So it's not going clear around the unit circle in the counterclockwise direction. This is moving in the clockwise direction. So it's that smaller angle that's showing here. It says the figure shows an angle theta in standard position with its terminal side intersecting the unit circle. Evaluate the 6 circular function values of theta. Now there's a lot of different ways to do this. I'll try and take the easiest approach. Now if we blow up this picture just a little bit and kind of see what's going on here in quadrant 4, I have something that looks like this. And then I have the circular piece that kind of comes in like that. And I know that this point right here is given to me as 12 over 13 and negative 5 over 13 because I know I'm in quadrant 4. So I'll leave that information up there just a little bit. Well, if you want to think about this in terms of triangles, you could bring up an altitude to hit the x-axis. And in the x direction, I know that this is 12/13. In the y direction, this vertical distance, that's negative 5/13. And then this is my radius of my circle, r. Well, you can use Pythagorean's theorem, or you can use the formula x squared plus y squared equals r squared. You'll get the exact same thing. And I would get 12 over 13 squared. So Pythagorean's theorem. Or x squared plus y squared equals r squared that we learned back quite a while ago. And we get 12 over 13 quantity squared plus a negative 5 over 13 squared equals r squared. Now note, this is an important thing. Negative 5 over 13 squared does not equal negative 5 quantity over 13 squared. So this one I'm only squaring the 5, and then I make it negative. So I get negative 25 over 13. This means to take negative 5/13 times itself, and that's really what we need to be doing here. So 12 squared is 144, 13 squared is 169. Negative 5 times negative 5 is a positive 25. 13 squared again is 169. And 144 plus 25 would be 169 over 169, which is 1. So here I get r squared equals 1, which means r is equal to plus or minus 1. Radius is not, we're not looking at in terms of direction, but just a length. So this is r is equal to a positive 1. So that could be one way that we could start this. So I know I'm working with the unit circle here. So I just figured out that r is 1. And I also know that this is my x and this is my y value, so I could start writing my trig functions. I'm going to go ahead and call this angle theta like they have here. So sine of theta is y over r from our unit circle. But r is equal to 1 in this case, so that's just my y value. So as soon as I establish that we have a radius of 1, these become really straightforward problems. Sine theta, that would mean cosecant theta would be the reciprocal. It's 1 over sine. So it'd be a negative 13 over 5. Now the fact that the negative is on top for both is just fine. You don't want to put the negative in the denominator because it gets lost. Here I have cosine theta, that's x over r. R is 1, so this is just x, and I'd have 12 over 13. Secant is the reciprocal, so it would be 1 over the cosine of theta. And that's the reciprocal of 12 over 13, so that's 13 over 12. Last one would be tangent of theta, y over x. I don't have an r to substitute in here, so I'm going to take y, which was negative 5/13 from our diagram. X was 12 over 13. Now when you divide by a fraction, so I'm taking negative 5/13 divided by 12/13, I'm multiplying by the reciprocal. Reciprocal would be 13 over 12. 13's canceled, I'm left with negative 5/12. Well, real quickly then, the cotangent would be the reciprocal of that, be a negative 12/5. Okay, so this became really easy once I had a radius of 1. Not all of these will have a radius of 1, however, so you always need to check. Now here's another type of problem that you'll see in your homework set. It says find the value of s. Now remember, s is the same as theta, and this is in radians, in the interval 0 to pi over 2, so this is quadrant 1, that satisfies the given statement. It says what angle has a tangent of 0.8237? So what angle has a tangent, actually let's go back. What angle in quadrant 1? We'll put that in right away. What angle in quadrant 1 has a tangent of 0.8237? That's the question that this is asking. Well, I don't know the answer to that, so I'm going to have to grab a calculator, and in order to figure this out, I'm going to have to use my inverse tangent. But the first thing we want to do is make sure we're in radian mode, and we are. So we'll go inverse tangent, and I have 0.8237. So this is going to give me an angle, the least positive angle, in this case it'll be in the first quadrant, that has a tangent of 0.8237. And so I get 0.6890 for this particular case. So let's go ahead and write that out, how we checked it. You have to use your inverse tangent key. And this might say, let's say round to 8 places. So I have 1, 2, 3, 4, 5, 6, 7, 8. That gives me that value of 2. So I have 0.689026, and then this value of 9, we'll round that up to a 3. So rounding to 8 places, I'd get 0.68902603. So just make sure you read the directions, because sometimes it'll say exact form, sometimes it will say rounded to so many places. Let's do another one of these that has not one of the standard sine, cosine, tangent functions, but has one of the reciprocal functions, in this place cosecant. So how would we use our calculators for this? Well, let's ask what the question is first. It says find a value of s in the interval. So s, remember, is the same as theta, and we're working in radians because I'm using that value. 0 to pi over 2 means I'm in quadrant 1. That satisfies the given statement. Cosecant of s equals 1.3513. So I'm looking for s, so I'm looking for an angle. So what angle in quadrant 1 And it's important to specify because there's actually an infinite number of solutions here unless we're restricted to the first quadrant. So what angle in quadrant 1 has a cosecant of 1.3513? That's my question. Well, the reciprocal of cosecant, if you recall, is sine. So what angle in quadrant 1 then has a sine of 1 over 1.3513? This would be the same question. Well, I don't know the answer to that one either. We have to grab a calculator. It's not a standard angle that I'm aware of. So we're working in radians here. So let's come up here and look, and it does say radian. I'm going to clear everything out. So I'm going to have to say inverse sine in this particular case. So second inverse sine, because I don't have an inverse cosecant. And instead of putting in the 1.3513, I'll put in 1 over that for the reciprocal. So 1.35 goes into the denominator. And for this one then I get the 0.83311, etc. Let's go ahead and copy that. And we'll put that in our notes as well. Now if we were to ask to round this, let's say to 2 places, it'd be 0.83. If we were asked to round this to 8 places, I think we know how to round it. So you just need to make sure that you read the instructions on rounding, and each one will be a little bit different. Now sometimes I don't have to be in quadrant 1, I could be in other quadrants. Okay, so for this one it's going to be a little bit different because if you notice I'm not in quadrant 1, I'm in quadrant pi over 2 to pi, which would be quadrant 2. So let's go ahead and circle this one so we know that that problem's done. Let's have a look. It says find the exact value of s. So that means we're working with theta in radians. And given the circular functional value, it says do not use a calculator. So this one we should know this because it's a standard angle. Here we're in quadrant 2. Pi over 2 to pi is quadrant 2. So right away this says what angle in quadrant 2 has a sine of 1/2. And I know something about this because I know that the sine of pi over 6, or the sine of 30 degrees, is equal to 1/2. So it has to be some angle with a reference angle of pi over 6 or 30 degrees. So if I draw out my unit circle here, I can do that. My reference angle 30 degrees in quadrant 1 would bounce back to a reference angle over here of 150 degrees, or 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So the angle I'm looking for then is s equal 5 pi over 6. Now it says type an exact answer using pi as needed. It says use integers or fractions for any numbers in the expression. That means we can't use decimals. So that would be my 5 pi over 6. And if you don't know memorize your unit circle, or you don't know your unit circle, you'd have a tough time coming up with this. So again, in order to work efficiently in trig, you really need to know your unit circle. It'll be very important. So for our next one, they give us a picture like a graphing calculator output here. And if you notice the point that's marked right here, the coordinates are given down here for that. So this is the x value and this is the y value. So the x value would be 0.65311926. The y value is 0.75725506. So what they say here is, it shows a point on the unit circle. It says, what is the length of the shortest arc of the circle from 1, 0 to this point? So here's the point 1, 0. They want to know the length of the shortest arc. That means they don't want you to go 3 or 4 times around the unit circle. They want to go the shortest, so that would be this length right here. So if we want to know an arc length, remember arc length is equal to s. S equals r theta. Theta has to be in radians. So I want to find s, and in order to find s, I think I need to know r and theta then. So here would be my value for r, and here would be my value for theta. So we need to figure out how we can find those. Well, let's kind of blow up this quadrant a little bit and see what we have going on there. So this is 1, 0, and then this is that point on the arc, 0.6531196, and 0.757255506 is my y value. Okay, so there's several different ways that we could solve this. Remember, we want to find theta, and we need to find r. Well, I think the fastest way to find r would be like a Pythagorean theorem, or use x squared plus y squared equals r squared. And really they're the same thing. So x squared would be the point 6531196 squared plus y squared 0.757255506 squared equals r squared. So to do anything else from here, we're going to need a calculator, so let's go ahead and pull in that calculator. We'll try that again. So I have 0.65311, and we want to have this in parentheses. It doesn't matter for this particular problem, but if either one of these was a negative x or a negative y, we would have to have it in parentheses when I square it. So this is 0.6531196. So just for consistency's sake, let's go ahead and put parentheses around it. 0.757 25506. So I get r squared equals, okay, that just popped off the screen, so let's bring that back in. And I noticed there was an e on there, by the way. So this value for e, this is putting this solution in scientific notation, and I think I know why it did it, because I entered it wrong. So let's go ahead and clear that. Let's go back up. And if you notice, I forgot the decimal right there. And so our number was huge, and it shouldn't have been that big. So I'm going to do a second insert, and I'm going to insert a decimal. I think our answer will be much more reasonable now. So I get r squared equals 0. Lots of nines. So let's go ahead and count those nines. I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then it ends in 3, 7. So if we take the square root of that number, so if we take that to the 0.5 or take the square root, I get almost the identical number because it's so close to 1. So I get 0.1, 2, 3, 4, 5, 6, 7, 8 nines again. But this ends in 6, 8 now. So that's my value for r. So I know my value for r now. Now I need to figure out what my value is for theta. Well, I think the easiest way to work on this to solve for theta is to kind of think about what our ratios are here. So I know a value for x and y. That wouldn't be sine or cosine because I'd need to know r. And I do know r here, but I could have a mistake. I should go with the original numbers that were given. So for this particular case, I could do tangent theta equals y over x. So tangent theta would be y, 0.757255506, over x, which is 0.6531196. So let's go ahead and divide that out. And then when we get done, I can say theta would be the inverse tangent of that. Now I don't want to round anything, as tempting as it would be to not have to write all these out. Because once I start rounding, I'll start throwing off my answer. So let's go ahead and put this into the calculator. So I'm going to go second inverse tangent. I'm going to have a fraction, so I want to use my fraction key to make sure I have the correct numerator and denominator positions. 0.757255506 for my value for y and my value for x, 0.65311,926. Close parenthesis. So this is going to tell me that angle in quadrant 1. Okay, so 0.859, so theta equals 0.8591, 1, 2, 3, 4, 5, 1. So if I want to find my answer now, that arc length, remember S is equal to r theta. So arc length is equal to my radius, and I don't want to do any rounding. And then theta, I'm running out of room here, so I'm going to go ahead and write it right below. I'm multiplying these. Okay, so I'm going to take that answer that you see right here, the 0.859, I'm going to multiply that by 0.68. And so my arc length then would be the 0.859, etc. Zero 999,974, and of course you would round that appropriately from there, but that's my arc length. So if they wanted us to round to one place, it'd be 0.9, 2 places would be 0.86, 3 places would be 0.859, 4 places would be 0.8591. So just make sure you read the directions carefully about rounding. Now when you're working the last few problems in here, you're going to apply this idea of arc length, this idea of plugging in values, and also the concept of the unit circle and how it relates to our trig functions. So all of the information we've learned so far is finally coming together here. As usual, if you have questions, please feel free to shoot me a text and send me a screenshot of the question in your work, and I'd be happy to help out. Good luck!